My name is Francesco, and I'm here to talk about the future of traceability, physical traceability in particular. So let's start from this picture. What you see is two identical bags, the iconic Birkin from Hermes. So the thing is that the one on the left sold a couple of weeks ago in Paris for about 10 million. The one on the right is a so-called super fake, so a copy so close to the original that even brand experts would struggle in identifying it. So the problem with authentication is typically that it's either a very time-consuming and expensive process, or in some way is a subjective process. So what we want to do with Elementag is to make it fully objective, quick, and accurate. So clearly with traceability, one problem is counterfeiting, which is, however, not limited to the luxury space, but it really touches any industry and any geography. There is another problem which is a bit more subtle. So there are certain categories that are simply hard to trace with traditional technologies like QR codes, NFCs, or RFIDs. Think about raw materials, think about semi-finished products, or items with a second-hand life. So the limitations tend to be similar among these technologies. So they are visible, they can be easily copied, damaged, or removed, but most importantly, they do not withstand any sort of processing, so they can be applied only to finished items. Elementag overcomes all these limitations while preserving some of the desirable features like high encoding capacity and on-site readability. So how it works is actually quite simple. We associate a set of information to the chemical composition of a nanomaterial, which can be fully embedded into the item, becoming really a sort of inorganic DNA, which can be detected then with a portable device on-site in a non-destructive analysis. So these are some of the materials that we tested. So it's an extremely versatile technology applicable to industrial components or artworks in the same way. And clearly, there is no impact whatsoever on mechanical functional properties of the material itself. So it's like extremely seamless and invisible. We have already 10 pilot projects up and running with clients in different industries, spanning from defense to automotive, from luxury to art. And with a couple of customers, we're starting to discuss how to go from the R&D phase to the full industrial scale-up. With about estimates for 2026 of 1.7 million in recurring revenues, very sticky given the integration that is required. So the team clearly is very strong when it comes to chemistry and material science, but we have also previous experience in launching and scaling products across Europe. And we're currently looking for 2.5 million with about 1 in soft commitment already. In terms of use of funds, the vast majority is going to go towards industrialization, meaning production capacity expansion, team, and in part, software development and lab equipment. So thank you very much, and if you want to hear more, I'm happy to have a chat afterwards.